Okay. So thanks, everybody. Welcome to the new year. Happy New Year to everybody. This is our first meetup for 2023. We started out as a in-person meetup in the San Francisco Bay Area. And with the pandemic, we moved into a virtual format, our virtual format. And then we also became a global meetup during the pandemic as well. So we changed our name to Enterprise Global Meetup, Enterprise Agile Global. We have a YouTube channel where we record all of these videos and put that there. We also have the presentations that people share, like similar to Seb is going to share after this meeting. We'll share that with the group as well. Our focus is how to scale Agile across the enterprise. So it's not just the pure process piece, it process, tools, quality is a major aspect of it. And today's focus is the quality. We are, a group of people from different dimensions, project managers, scrum masters, engineering leaders, product managers, engineering managers, etc. And this is a major topic that touches all the different walks of people, whether it's from novice to expert. So welcome everybody to this first meetup. And we usually do like one meetup a month. So we already have a couple of things lined up for next month and February and early March. Diane, who wrote the book on Agile retrospectives, is going to come in next month. And then we also have Agile and OKRs, a meetup schedule with for late in February as well. So, and we are going to have a few others coming up later in the year, after Q1 as well. So with that said, I just want to quickly introduce Seb. Thank you. First of all, thank you, Seb, for taking the time and staying up late to do this topic. Quality is very near and dear to all of us, especially to me. And contract testing is a major thing, especially in this world of cloud native and microservices. Seb has written major books on BDD, TDD, and he has done a lot of consulting work, good work on quality. And he's also the co-developer for Cucumber as a tool as well. So without much further ado, I want to hand it over to Seb. Thank you so much, and welcome to the meetup. Thank you for spending time and sharing your knowledge nuggets.
Thank you very much, Gopal. So I'm sharing my screen. I think you can.
I'm sorry, Seb. I just want to mention one quick thing. Sure. Miro is our sponsor, and we had a quick intro about Miro as well. So thanks, Miro, for sponsoring this meetup starting in 2023. Please go ahead, Seb.
Okay, thanks, Gopal. So thanks for the intro. My name is Seb. You'll see on this slide, there's lots of ways of getting in touch with me. My plan is to do this talk in about 40 minutes and then leave 20 minutes for questions. Things don't always go quite according to plan. So if you do have any questions and you don't get a chance to ask them, there you can get me on the Fediverse, on Twitter, or you can email me. A favor that I'd like to ask you all is, you see this QR code in the top right-hand corner? There's a really, really short questionnaire that comes from the open source tool Pact, which you'll find out more about as I go through the talk. If you could possibly just take a quick photo or go through, scan this QR code and go to the link, you fill in the questionnaire as I talk or at the end. It really doesn't take very much time, but it gives us a little bit of information about who attends this meetup and also where you are in your contract testing journey. So with that out of the way, I'm going to be talking about software contracts. And for me, software contracts are an important technical aspect of software development that will really unlock agility in this world of decoupled individual components, which is often where we talk about microservices. So I use microservices in the title because that's the buzzword at the moment. But in fact, even without microservices, we still have lots of small components that interact with each other. And so we're going to talk a lot about contracts. We will talk about contract testing, and then we will talk about open source contract testing tools. And I don't want to in any way disagree with what Gopal said about how quality is important, but I do want to stress at the beginning and to make it quite clear as we go through that contract testing, although it's got the word test in the title, it's not a testing activity, as in it's not a QA activity. And this will come up a number of times as we go through. The truth is that a lot of the work that we as software developers, as product owners, as project managers, as designers, a lot of the work that we do is testing. But that's not necessarily the same as being a quality assurance or a tester per se. So let's see how we go as we go through. So the session's on software contracts and within the context of microservices and agility. And the first thing that I want to really stress is that microservices themselves have been trumpeted as a fix to a lot of problems that we see in software teams and software organizations. We'll go through some of the supposed benefits of microservices in a second, but actually a lot of the silver bullet type solutions to problems are a bit like a heffalump trap. Now, some of you may not have come across the heffalump. The heffalump was a creature that was imagined by Winnie the Pooh and Piglet in some of the famous books by A. Milne. And they were very frightened about this heffalump. And so they dug a big hole to trap it to make sure that it didn't hurt them. Unfortunately, the only people ended up getting caught in the heffalump trap were Winnie the Pooh and Piglet themselves. And this is a warning to us, not just to jump on the first silver bullet bandwagon, because quite often we jump in feet first to the shiny squirrel, the new technology that's going to solve all of our problems. And 3 months later, 6 months later, or indeed 6 years later, we discover that that shiny tool has dug us a very big heffalump trap, and we are stuck at the bottom of it. So nothing that I'm saying today should be taken as a silver bullet, and everything should be taken with a fair dose of context. So a definition. This comes from the microservices.io website. I've edited it slightly to fit on the slide, but they define a microservice architecture as a collection of services that are independently deployable, loosely coupled, organized around business capabilities, owned by a small team, highly maintainable and testable. There's another way that you could describe, you could capture all of these 5 points and say a collection of services that can be built, deployed, and managed in an agile way. Because each of these items here is going to contribute to agility. And here I'm talking about small a agility, i.e. the ability to respond to change in a timely fashion. I don't doubt that any of you on this call have got any arguments about the benefits of these 5 principles or properties of services. So this is the context that we're going to be talking about. Microservices delivering the ability, or at least the capability, for large, highly technical, highly complex applications to be delivered in an agile way. And the microservices.io goes on to stress it in a different way. This enables rapid, frequent, reliable delivery of large, complex applications. However, of course, there are pitfalls. So you imagine yourself, you've got not just one microservice, because on one microservice on its own typically doesn't deliver a whole lot of value. And if you start looking at large organizations like e-commerce sites or banks or insurance companies, they will have dozens, possibly hundreds of microservices, maybe organized into sets or groupings of API products, but nonetheless, you've got a lot of microservices. And there are a number of pitfalls that come along with this if you just jump headfirst into this microservice architecture without really thinking about it. So the first one is you're working either on a product or a service yourself, and you've got some dependencies. but those dependencies aren't ready yet. So they're being built maybe at the same time, or maybe they're being scheduled to be built later on. So what are you supposed to do if you've got a microservice or an application and you depend on a microservice that isn't yet ready to be deployed to, or at least called? So that's a potential pitfall. Are you blocked? You would hope not, because one of the properties that we looked at, or was described earlier, is that we should be able to work in a decoupled way. How about if the microservice that you depend on doesn't actually provide the functionality that you need? How do you ask for that functionality, or who do you speak to work out what alternative functionality is available, or to understand why it's not there, that you maybe shouldn't be depending on this functionality? Perhaps you're already using a microservice, and yet that microservice team is evolving the implementation and possibly even the API of that microservice. How can you be confident that a new deployment of that microservice is going to behave in exactly the same way and not break any of your expectations? Finally, maybe you are the developer or on a team that develops and maintains a microservice, and you would like to enhance it or modify the API or possibly retire some parts of the functionality. But how do you know who in the ecosystem is using your microservice? Which calls are they making? What data are they providing? So there are a number of problems that you can see here. You've got these decoupled microservices, but what are the communication paths between them? How do you understand the impact of changes on the environment of all the microservices that you depend on and that may depend on you? So these is where the hefflumps live. This is the traps that you can fall into. And my colleague who currently works with SmartBear, which is where I work, but was one of the first developers of the Pact.io open source contract testing framework, she made some very wise statements a number of years ago. And it starts off with, if you can't deploy services independently, then you don't have microservices. You have a distributed monolith. And although I'm not going to be talking about monoliths today, that's what a lot of the microservice architecture impetus was caused by. The fact that we were building monolithic applications that took months to make the smallest change to and months to do any quality assurance of. And so we tried to split them up into microservices that we could deploy independently. And yet many teams have found themselves in a place where they have many microservices, but they still have to put them all together in an integration environment and test them together exhaustively before deploying them in a synchronized way. And that's absolutely not delivering on the promises of microservices. So that's a brief introduction to microservices and the pitfalls and the benefits that they may deliver. If you've almost had enough already, here's the TLDR. And the TLDR of this session is that all interactions between software components, whether they are microservices or other components, could be applications, could be systems, could just be classes within the implementation. All interactions are governed by contracts. That is, each side knows what it should be able to provide, what it should be able to ask of the other side, and the other side, if its requirements are satisfied, should be able to provide a valid answer or an understandable error message. These are contracts. Contract testing, which is what we're going to get to towards the end of the session, ensures that both sides of that contract have the same expectations. So when we're dealing with contracts with a real estate agent or with someone hiring a car off, there's a printed document and we can both read it. It's governed by legal frameworks in whatever country you're in. You sign it at the bottom and you each take a copy away. So many of the components that we interact with have documentation that is possibly more understandable than those legal texts, but less enforceable and more ambiguous. So contract testing is one way of getting to the point that you have that both sides of the agreement really understand what's being agreed to without having to go into really deep legal texts that are hard to understand. And the final the point that I will leave you with, and I'm giving you up front, is that contract testing is not a QA activity. Contract tests describe the interaction between a consumer of a contract or a consumer of a service and a provider of that service. And it's part of the development activity. Your testers and your QA engineers may be involved at the same time as you are writing these contract tests, but these contract tests are part of the developer's activity. It's the developer's responsibility to craft them, understand them, and indeed maintain them. Which then takes us onto the greater agenda. Not all of these have got very many slides or much content to them, but I want to talk through contracts, software contracts from a high-level view through to, typical development activities of decoupling components or microservices from each other. That will lead us on to contract testing, dependencies, and we'll finish up with Pact and Pact Broker, which are a couple of free open source tools to make a lot of this, certainly make the implementation of it simpler. So, software contracts. So this is a schematic of a very simple application. So you can imagine that X is the UI, and the UI talks, whether it be through web proxies or remote procedure calls or HTTPS or whatever, it talks to a number of components that it depends on to deliver services to the end user. And the top set of components, just the blue circles, here I'm thinking about maybe it's a DLL, maybe it's a library of C# code. It's some sort of support code that's been written by your development team. So your UI will interact with that in some way. Equally, your UI may interact with cloud services, so AWS or Google Cloud will have some other functionality deployed on it on which your application depends. And frequently, your application may depend on a database hosted possibly in the cloud or somewhere on a server farm. Probably the applications that you're working on have many more than these handful of dependencies that's shown in this diagram. Yet this is already quite a complicated diagram to discuss in a session that's as short as this. Just to be clear here, the interactions between X and each of those dependencies, those are governed by contracts. So they are collaborations in the sense that X collaborates with the cloud, X collaborates with the database, X collaborates with the C# or Visual Basic Code to get some service rendered for it. And there are contracts that govern those dependencies. This, as I said, is already too complicated a diagram to discuss here. So for the rest of the session, I'm going to be talking about just two components interacting with each other. We have the C for the consumer and the P for the provider. So we can imagine these as class libraries, or we can imagine them as microservices. And for the purposes of today, let's think that they're microservices. So C is a microservice that consumes some sort of functionality that is provided by P, the provider. And again, for clarity, that interaction is governed by a contract that both sides should understand. Now, the idea of how contracts that govern interaction between software components is not a new idea. A gentleman by the name of Bertrand Meyer wrote this book in the 80s, I believe, or maybe it was the early 90s, called Object-Oriented Software Construction. In it, he described the evolution of a language that he invented. The language is called Eiffel. Some of you on this call may have heard of Eiffel. I don't even guess. I am certain that none of you on this call use Eiffel, because as a language, it did not capture the imagination of the marketplace. However, it had some really good concepts inside it, and these are concepts that have been borrowed and reused by various organizations from Microsoft on outwards into the whole ecosystem. And one of them is that each contract should be explicitly stated as an agreement between the client and the supplier. And when you get to the point of saying, well, or at least accepting that there is a contract that governs your interactions, or the interactions between the consumer and the provider, then the consumer and the provider should both expect that this contract, the knowledge of this contract and the explicitness of this contract should give some benefits. Otherwise, why would we bother doing it? And those benefits are the benefits that we listed at the beginning, which essentially revolve around certainty about what's going to happen. If you behave in a particular way, then the component that you're interacting with will behave in an equally predictable way and deliver some value to you. However, the contract itself ensures that, or rather dictates that you have some obligations. And those obligations are that if you say that this is the contract that you are being governed by, then you must ensure that you code to that contract. That means that if it says that you must, that as a consumer, you must always provide a valid customer ID, then you must provide a valid customer ID. And if you don't, then you should expect an error message or undefined behavior. So the contract gives you certainty, it gives you the benefit of that certainty, but you have obligations to live within that contract in the same way that you don't go and crash the rental car. The contract will say that you have to pay for that. So there are two, let's do it a different way. Contracts exist already. So if you look at a class in C#, you will see that it has public methods. And those public methods talk about the parameters that should be passed to each one of those methods, how many parameters and what types of parameters should be. And they'll talk about a return value that will be returned by that method. That's a contract of sorts. That's what I would call an explicit contract. It's very clear about, it's written into the code. You can't argue with it. It's parsed by the compiler. It's enforced at runtime as well. This is the way it works. It's really hard and fast. And here to sort of, as a schematic of explicit contract, I'm showing a nut and a bolt, right? So in the world of nuts and bolts, you get bolts of all sorts of different sizes, and they have different thread pitches on them. And some of them have left-handed threads and some of them have right-handed threads. And if your bolt and your nut are of a different size or have a different form of thread, they just won't screw onto each other. That's an explicit contract. You can test it very quickly. You can look at it in the shop. You can look at the label on the bolts and the label on the nuts, and they will say this is a metric thread pitch of 10 mil, and this is a nut that is supposed to fit on a metric 10 mil thread, and it all works fine. These explicit contracts are great. They're a bit like your methods and parameters and return types in code, and yet there's more to it than that, because there are implicit aspects to many contracts. So if you look at this diagram, this nut and this bolt are trying to hold the two bits of metal together, the two bits of metal that are on the right-hand side. However, the bolt is too long to fit in the gap that is available. And so no matter how much you tighten that nut, you are never going to get those two pieces of metal to squash together. Equally, you sometimes get bolts that have got a section towards at the top that has no thread on it. In this case as well, you can tighten that nut all the way to the end of the thread, and it's never going to hold these two pieces of metal together. In the software world, implicit contracts are things that you should know about how a system works, but is not necessarily described explicitly in the code. So for instance, what sort of exceptions does the code throw? Well, some languages have tried to include explicit exception protocols in their code. That didn't go down particularly well, and it certainly hasn't been taken up universally. Equally, I was just mentioning about earlier on, I said, well, maybe there's a service that requires you to provide a valid customer ID. Well, how do you define a valid customer ID in the code? You might have to put it in the comments, but there's no explicit way of putting it in the code and having the compiler or the runtime check it. You just have to run it and hope that you got it right. And these are areas where we get lots and lots of problems because the implicit nature of a lot of the relationships mean that it's hard to know which order to call methods in, which services need to be called first, what tokens need to be passed. There's a lot of not quite fully documented behavior, which leads teams to use tools like Postman, etc., to try and really work out how the services you depend on are working, and then leads you to have to do really quite large amounts of integration testing to make sure that the assumptions that you've made are in fact correct when you run against the components that you depend upon. So I've been talking in the abstract about contracts, and I guess what I'd like to talk about now is where do they actually come from? You know, who creates them? Are all contracts the same? And the answer is contracts are not all the same. I like to think of the two different sort of flavors of contracts. You have contracts that are created by central bodies, such as maybe you know, and the Internet Forum or you know, W3 or various other standards groups. So they might be ISO standards, they might be language standards, it might be an industry standard. And these are generally, people get together in committees, they talk about them, they're representations from large companies, but you as a consumer of these contracts, you typically have very little influence over them. They release a version of the contract, you either like it or you hate it, you're told whether to use it or not. You may complain about it, you may make representations to the standards bodies, and then some years later, you may get some responses. But in general, provider contracts get delivered to you and you live with them whether you like it or not. So they're closed and complete, they're singular and authoritative, right? There's one standard, you've got to live within it. And they're really stable and generally immutable. So they do evolve over time. But they're pretty much immutable from your perspective. You just have to live with them. The other side of the coin is consumer-driven contracts, and this is way at the other end. And is general consumer-driven contracts are an approach that's used within an organization where a service or a number of services are being developed to satisfy other consumers also within the organization. And in consumer-driven contracts, the consumers express or describe how they would like to use a service, and they provide that then to the service provider, and the service provider uses that to guide their development. So they're open and incomplete because they're always changing, and the consumer is often going to come up with, you know, a certain area of this API or this service that it wants to use and describe how it wants to use it. But it's very usual for a consumer not to use every single method or method within an API. It will focus on areas of that API that deliver particular value to the behavior that it needs to deliver. So the consumer writes out in the contract, well, it's this area of the contract that I'm interested in, and this is the behavior that I need to satisfy my business objectives. We'd also like to think that the services that we provide, they're not just one-to-one, as in I create one provider and it will only have one consumer. We would like to see a bit more reuse there. And so typically every provider service will provide that service to multiple consumers. And therefore each consumer will create its own contract about how it expects the provider service to behave. Thus, consumer contracts are multiple and non-authoritative. It's the overlap of all consumer contracts that define how the provider service should behave. But like provider contracts, these contracts are valid for a particular period of time. So they are stable and immutable. So although what you might immediately think from what I just described earlier, that these consumer-driven contracts change at the whim of the consumer, that's absolutely not the case. They are stable. It's just that the consumers guide the development of those provider services by defining what value they are looking to get from them. So with that in mind, how would you agree a consumer contract? So if you are a very small team and you live, you work co-located in an office, or even maybe if you're working over Zoom, etc., maybe you can say you will have the consumer service and the provider service are being developed by the same team, or at least by people who are living and working close together. You can talk about it and you can play things backwards and forwards. You can have meetings and go over agenda. However, this is not typical of our organizations today. Back in the day when I was working in banks, we would often have open plan offices, and we would have consumer teams on one side of the office and a provider team, maybe if you're lucky, within walking distance of a water cooler on the other side. There you could get into a room together, you could thrash things out. Equally though, you might just be on different floors of a building, which makes it really hard to form a personal connection. Or indeed, in different buildings on a campus, or in different areas of an office, or more likely, you're distributed over the entire world. You've got development teams on every continent, and your provider team doesn't necessarily even know who the consumer teams are. How do we agree a contract? Well, the choices are you're given it and you have to live with it, which is the provider contract, the authoritative, single and authoritative contract that is written by a committee and then doesn't change, or you have to negotiate and document a contract. And negotiating and documenting a contract is really what contract testing is about. Whoa, I've got duplicates here, haven't I? Yes, I have. Excuse me. So, consumer-driven contracts. Each consumer captures their expectation from the provider in a separate contract. We'll have a look at that and how that gets done in a wee while. All of the contracts are shared with the provider. So basically, what we have is we have the consumer writing their contract about how they would like to interact with the provider. And once they've written that, they will then share it with the provider so that the provider can get insight of the obligations that the individual client is looking for. And then the provider creates a test suite to validate these obligations. So this might sound like quite a long, quite a problematic way of working. However, the tool that I will be talking about later on, although not a silver bullet, simplifies a lot of it. However, before we talk about silver bullet tools or whatever like that, what we're going to try and do is, well, we're not going to try and do, we're going to look at how we actually implement it without using a tool. So, first off, decoupling is a term that comes from software development, and I'm pretty sure that most of you on this call have heard it. But essentially, what we're trying to do is make sure that the components that interact with each other can work, work well together, but aren't so tightly coupled that you can't modify the implementation of one without breaking the other. And the other term that's in this title here is test doubles, and I will cover that when I get to it in 2 slides' time. So a monolithic approach to doing this form of development is that the developer writes a collaboration test of how the component that he's writing, the consumer, is going to interact with a provider service. And that collaboration test ensures that, that the outcome from the provider is as expected and that the behavior of the consumer is as specified. And if you are doing that without any decoupling, then you have to have a version of the provider present in the development environment so that you can test your consumer. Once you've done that, then you can ship to production, and you can be pretty sure that the consumer and the provider are going to continue working together. You've started with the consumer interacting directly with the provider when you were writing your collaboration test. You ran that collaboration test in development, it passed. Now you have some confidence, you can promote it into integration and hence to production, and it's still working with the same provider, and therefore it should still work. And just to remind you, the contract is a document that governs the interaction between the consumer and the provider. The trouble with this is it means you need to have a development environment within which the provider service can run. And some provider services, that would be fine, but many provider services, maybe for instance, if you're working with a credit card provider, there's a limited number of environments that they run in, and you can't always get access to them from your developer machine or from your CI environment. And so this is a limited, there's a limited benefit or limited applicability for this monolithic approach to test-driven development, or at least test-based development that allows you to interact with the provider service in all environments. So instead, we have a decoupled approach, which is where in collaboration tests that run inside dev, in the CI pipeline, and possibly even in some of your integration environments, the consumer doesn't interact with the provider service. It provides with a test double, something that you have coded to look and behave like the provider service, but to do it cheaply in memory, for instance, or maybe backing onto a file rather than into a database, something that emulates the provider service, but that doesn't require the same amount of resources to run it. And again, there's a contract here which governs those interactions, those collaborations. And we assume and hope that the contract between the consumer service and the test double is the same contract that governs the interactions and collaborations between the consumer service and the provider service. And when it works fine. You run the collaboration tests in development, in the CI pipeline, in some of your integration environments, and they pass. Eventually, you promote the consumer service into production, and it interacts with the provider service, and everything still works, and everybody's happy. However, that's not always what happens. Frequently, the collaboration tests pass in development and in the CI pipeline. And it's when it gets to production or maybe late stage integration that you get a failure of this test. And this is caused by the fact that the test double frequently doesn't have exactly the same behavior as the provider service. Because it's just a test double, it's not an exact replica. It's supposed to replicate the contract, but it's not a truly faithful replication. And this is a problem that doesn't just start with components. For those of you that come from a development background, you'll be aware of test-driven development and the fact that there are people who will be using stubs and mocks when they're developing their classes and their methods. And this same problem happens when you're using mocking frameworks and stubs. They are just another form of test double. And if you create your mocks with slightly differently from the classes or functions that they're mocking, then you get the same problem. It runs in test, but it fails when you actually put the consumer and the provider together for real. Which is where we get to contract tests. So contract tests were first described to me by a guy called J.B. Rainsberger, and he was using them to write code. So he's using them as part of his test-driven development activity. And what he identified was that the collaboration tests, i.e. the test where you are working on a component C and it's got to collaborate with some dependency, those collaboration tests are making assumptions about the contract. When you mock out or stub the provider service, that stub bakes in assumptions about the contract. And what's missing is any way of verifying that those assumptions are justified. And so what J.B. Rainsberger does in his development is he creates a contract test for each assumption. There's quite a lot more in this mailing list, so it's linked. That's not linked so much. It's in a Google mailing list, and you could search for it online if you're interested. And he goes into some detail about it. But in brief, a contract test is a test that you will run against the test double and against the provider service. Exactly the same code, test the test double and the provider service, and you expect the behavior of the test double and the provider service to be exactly the same. In the days that JB was writing about back in 2012, he implemented it schematically like this. There was an interface. Behind the interface was all the functionality of the provider service. Yet the contract test would sometimes instantiate the service, the interface, once with the test double as the implementation, and once with the provider services in the implementation. The contract test would get run twice, and it would be expected to pass for both the test double and for the provider service. And in that way, you gain confidence that the test double for the collaborations that you're interested in behaves in exactly the same way as the provider service that is in fact going to be providing the functionality once you hit production. And at this point, we might go, well, yeah, this seems complicated enough, right? It's going to be hard enough to write all these contract tests. But if we did write these contract tests, would it be sufficient? And unfortunately, the answer is even doing this is insufficient in the world of continuous integration, continuous delivery, and continuous deployment that we have today. Because we've also got to try and stick with that mantra that Beth Scurry gave us right at the beginning, which is we need to be able to deploy our microservices independently. Otherwise, what we get is a distributed monolith, not the flexible and agile component ecosystem that microservices promise to deliver. So at this point, we have to look at how we manage dependencies inside a CI pipeline. This is a schematic of two CI pipelines, two massively simplified CI pipelines. The first one is the consumer service, which is going to go through check-in and develop the initial stage of the CI pipeline through into staging and then into prod. And then the second CI pipeline is for the provider service. It's again going to be checked in and built in the CI stage. Then if that passes, it can get promoted to staging. And then if it passes there, it can get promoted into production. And you'll see that I've given each one of them a subscript. So version 1 of the consumer is in production at the moment, and version 1 of the provider is in production. And in staging, we have version 2 of the consumer and version 2 of the provider. And in the CI stage, we have version 3 of the consumer and version 3 of the provider. And so, you know, we can think to ourselves, these are all being upgraded, developed, enhanced, and moving through the CI pipeline to production where they can deliver value to our customer. And of course, we're wanting to make sure that the consumer and the provider have both got the same understanding of the contract that governs the way they interact. So on inspection, it seems clear, doesn't it, that we need to make sure, well, if C1 and P1 are both in production, C1 had better work with P1. And likewise, if C2 and P2 are both in staging, we would like to make sure that C2 and P2 adhere to the same contract. And likewise for C3 and P3 that have just been checked in. Yet this isn't sufficient, because what if we wanted to promote C3 to staging, but P3 isn't ready yet? Maybe there's more functionality that needs to be delivered. Maybe there's an enhancement request from another consumer. Maybe we just don't want to do this in lockstep. We want to minimize the risk by just promoting one component at a time. Well, then we need to make sure that C3 works with P2 before we can move C3 up to staging. And we also want to make sure that C2 works with P1 before we promote C2 into production. But maybe it's not the consumer that we want to promote first. Maybe it's the provider that we want to promote first. Well, now we need to make sure that the C2 that's in staging works with P3 before we promote P3 into staging. And likewise, we want to make sure that the P2 works with C1 before we promote P2 into production. And this is just 2 components and only 3 stages in a CI pipeline. And you will have more components than that, and you will probably have more stages in your pipeline than this. Now we've got quite a lot of tests to run to be confident to be able to promote a component independently of another one. And this is where tooling comes in. And again, before I talk about Pact and Pact Broker, I really want to stress here, it's not a silver bullet. Once I've finished this presentation, if it feels like it's of interest to you, please go away and have a look at them. There's great documentation on the pact.io website, but you need to understand what you're getting into, because it's a tool, and tools can help you when you understand them and their constraints. So Pact is a tool that was actually built in Australia by some folk that were working on websites, I think, that was selling secondhand cars. And they were using a microservice architecture, and they wanted a mechanism that created and enforced, or at least created and validated, a contract between a consumer and a provider. And this is what the Pact open source tool was created to do. The way the Pact tool works is that the consumer, when writing their unit tests, uses a domain-specific language that's been provided by Pact to essentially to create test doubles. So Pact was initially created for HTTP-based services. So what the DSL does in your unit test is it essentially defines what the endpoint is in the service that you want to contact, and what data you expect to be passed to it, and what payload should be returned if that data is passed. You're creating a mock, although instead of creating a mock completely by hand, you're creating a mock using the Pact domain-specific language, which has been designed for creating these forms of mocks. Then, when you run your unit tests, Pact itself spins up a mock HTTP server and initiates it or instantiates it using the DSL that you have written in your unit test. And it then runs your test, and the interaction, your test calls the component that you're trying to test. It makes a call out to this mock HTTP server, which validates the parameters and then returns the payload that you've asked it to return. But the trick here is that as it does this, it creates a transcript of these interactions. So the interactions between the consumer and the provider are recorded in a Pact file. This Pact file is, you can inspect it. It's a text file, it's JSON, and it documents the interactions between the consumer and the provider, or at least it's documenting the expected interactions from the consumer point of view between the consumer and a mock provider. that Pact file is then given to the provider team. And the provider team then use Pact as themselves to generate the calls to the provider service using the transcript as the input. So essentially the transcript is then replayed, but in this time it's Pact generates the calls from the consumer and actually calls to the real life provider that the provider team is writing. And this then should return, the provider should return exactly the same payloads as were returned in the mock and is recorded in the transcript. And so this is used to verify the compatibility between the consumer and the provider service. The provider typically also has to offer a way of setting state to start with. So for instance, if your consumer, the test of your consumer, you want to make sure that it behaves correctly if there are no valid customers, then you will need to tell your provider service in the setup when it does the verification, there should be no valid customers in the database. And that makes life a bit harder. I don't want to go into too much of these details here because I'm already well out of time. The workflow, however, is this. The consumer CI runs its unit tests that have been written using the Pact DSL. That creates a Pact file, a JSON Pact file, which is a transcript of the interaction, which then gets published or uploaded to the Pact broker, at which point the provider can pull down this new Pact file, this new transcript, and validate it. This is a very simplified diagram. There's a YouTube link at the bottom for a video that gives you more detail. And here's a slightly more detailed workflow, which shows the consumer CI publishing the contract to Pact broker, and then the webhook kicking off the provider CI automatically to validate that contract, and then publish the results back to the consumer CI. So without any human interaction, we can validate that a change to the consumer CI, to the consumer service, is still supported by the provider. The Pact broker itself maintains a matrix of interactions between every consumer and every provider. So you remember I was showing you the two CI pipelines and the various tests that you wanted to make, where you don't have to do those tests each time you come to promote, because in reality, as long as you've run those tests once between a given version of the consumer and a given version of the provider, that result will happen every time you combine that version of the consumer with that version of the provider. So what the Pact broker does is it keeps a record of every test run between a consumer version and a provider version. In this example matrix that I show you here, I'm showing version numbers as integers. More typically, if you're using GitHub or Git or one of the other version control systems, these will be SHAs, which identify a particular state of the source code. And the joy is that once you have got this matrix populated, if you want to promote version 99 of the consumer into production, all you have to do is know what version of provider is in production, and then look up in the matrix to see whether consumer 99 and provider version 67 have been tested together. And if they have, you just look to see whether this verification result was success or failure. If it was failure, then it's not safe to promote that service into production. And if it's success, then it's potentially safe to promote that version into production. This then gives us the ability to assure ourselves of compatibility of two services very, very quickly. And in fact, the Pact tool ships with a command line utility called Can I Deploy, which does exactly this, which it looks at the version of the component you're trying to promote, and it looks at the version of the providers or the components that it depends on or depend on it in the next environment you're promoting to, and it just looks up those values in milliseconds within the matrix and gives you a green for go or a red for no, you need to have a think about this. And this, of course, is important when you get to, really quite much more busy CI pipelines than the one I showed you earlier. So even here, this is a way simplified CI pipeline, and it only has 5 components in it. But you can begin to think already, if you had to draw those arrows between all of the different components here, you would end up with many dozens of tests that would need to be run if you wanted to promote a component independently. So the key points about Pact Broker are that the Pacts, which are the transcripts, are published by the consumer. Tests are written by the consumer. The unit tests generate those transcripts. Those transcripts are published by the consumer to the broker. Those transcripts, those Pacts, are then fetched by the provider, which will verify them by running them against the provider service. The success or failure result will be stored in the matrix, and that matrix supports independent deployment of your components into an arbitrary environment. Pact, as I've said, is a free open source piece of software. It's extremely powerful and full featured. We have also created we've created Pact Flow, which, among other things, has a fully managed Pact Broker environment in the cloud. So Pact Flow doesn't offer much functionality above Pact, but it does make it simpler to deploy. So if you get a chance, have a look at both Pact and Pact Flow and think about whether they might help with what you're trying to achieve. And so, takeaways. Contract testing, whether you use Pact or whether you hand roll it, it increases agility and confidence because it means that you can do small, fast, rapid tests in developer environments without needing to have a huge infrastructure of all the dependencies ready and waiting. And that then the contract testing allows you to be confident that your test doubles actually behave in the same way that your real life provider services behave. And that reduces the need for integration tests. Doesn't remove the need for integration tests, but it means that you can be pretty sure that your assumptions about the contract that's governing the interaction between consumers and providers has been both stated in the contract test and verified by running the contract test against both the test double and the provider service. This speeds up development. So it speeds up, and it doesn't just speed up development, it also decouples development because the consumer and the provider can work at their own speed, depending on what resources are available to them. But it speeds up development because by having fewer integration tests, by having less, long, brittle, fragile tests that need a lot of TLC to keep them running, you get a lot of fast value from your unit tests, and yet you get the confidence from the contract tests, allowing you to keep moving in an agile and fast way. However, contract testing is no substitute for communication. So if there is a failure in the contract verification, it doesn't mean that the consumer did something wrong. It doesn't mean that the provider implemented it incorrectly. It means that you need to speak to each other, one team to another, and go, I expected the provider service to behave like this, and provider service explains, no, you've misunderstood it, we need to improve our documentation, etc. So what the failed test tells you is that there has been a miscommunication, not that one side or the other has made a mistake. And also, contract testing is a development activity. Despite the fact that it's called contract testing, it's something that gets done during the development of a component, and developers need to be closely involved with that. And then it should come as no surprise that it doesn't replace other forms of testing. So you'll still need to do penetration testing, integration testing, smoke testing, etc. You will just need to do less of it, and you will be able to get to that point faster because your unit tests, your repeatable fast tests, give you more confidence than they do currently. These slides are available on SlideShare. That QR code will take you to them. There's a repetition of the questionnaire QR code. Please help us by filling that in. It really does only take 30 seconds. And I'm punting or publicizing and advertising my BDD books that I've written with Gashver Nodge, which you can get via bddbooks.com. And with that, I would be very happy to take any questions that people have, if indeed you have any.
Do we have questions?
Hey, Seb, I've got a question here. It's Gareth Burns. Seb, that was a great presentation, so thank you very, very much for that. I was just wondering, Seb, how Pact actually determines the dependencies between microservices?
So Pact doesn't determine them. The consumer, when they write their unit tests using the DSL, they say which service they are calling, and so they're declaratively saying what service they're calling, and then that will look up the service in the matrix.
Okay, thank you.
And Seb, for this to work, supposing that consumer and provider are different organizations or teams, it looks like they both need to buy into the Pact concept for this to work as the broker. Is that true?
So if you're going to do it with the broker, yes. I've personally, when it comes to Pact broker, I have seen this working best when it's inter-organization, not inter-organization. Now, if you have a very close relationship to another organization, then potentially Pact broker might work for you. But in general, I see this mainly within an organization where you have dozens of teams all developing services that are used within the organization. PactFlow itself comes with, having said it didn't have much extra functionality, PactFlow comes with a feature that they have called bidirectional contract testing. And that is when, if you are a consumer of somebody else's service and they publish a specification using Open API spec or something like that, then it will validate your consumer calls against their published specification. It's a weaker level of confidence, but it does at least give you some level of safety against changes at the provider side. And another approach that I have seen tried occasionally is where a consumer team will publish an endpoint where people can contribute their consumer contracts, their Pact files, and then consume them for validation. But the truth is that if you really want that tight integration between consumer and provider teams, it's very hard to do that across organizational boundaries.
Definitely understand and agree as trying to evaluate both scenarios. Absolutely, if you're within an organization and leadership can declare or the organization jointly can assert, yes, we will all use this tool, it's going to work better. Is trying to understand, because we've had, well, in the news occasionally there are interesting failures when one service is relied on by some other organization and something goes down. Didn't know if this could be a potential solution. It sounds like it could if they all agree and choose to use it actively, but with less strength, as you mentioned, than if it was all in-house.
Yeah.
Thank you.
No worries.
Hi, I have a question. In our organization, one of the things that we've been doing is we've been moving in the direction of interfaces such as GraphQL away from REST, explicitly with the idea of removing the number of things that the client and the server have to agree upon. So in the case of GraphQL, we don't have to decide the shape of the request ahead of time. And I'm wondering if you have seen, as those kind of technologies take hold, has that been making your job easier, harder in terms of keeping compatibility across these releases, or just what have you seen in this area?
Yeah, so I mean, Pact was created to work with REST services. It then moved into messaging buses, and GraphQL is certainly on the agenda too. So it can be supported, even though GraphQL is less, structurally restrictive. There's so many more things to a contract than just the structure. So even in GraphQL, you can have malformed requests. You can have misunderstandings of what the behavior is supposed to be. And so I think there is still a need for this sort of interaction, because with the best will in the world, a service, just because it's got a GraphQL endpoint, doesn't mean it's simple or cheap enough to have it running in every developer environment that you've got. And as soon as you start decoupling things and replacing them in some test environments with test doubles, then you're in this situation where you're going to want to have some sort of mechanism to validate your test doubles authenticity. Does that make sense?
Yeah, it does. Thank you.
All right, it sounds like we've run out of questions.
Yep.
And before everyone leaves, I want a round of remote applause for Seb, and thank you for presenting today.
My pleasure.
All right, so I will stop the recording.
Recording, yeah. Like I said at the beginning, if you start on a Pact journey or a contract testing journey and you have questions, please don't hesitate to get in touch with me. It's, as I say on every training course I give and every talk I give, it's a very cheap offer because none of you ever do. But if you do, I will respond to you. So there you go. That's my commitment.